Okay, so the PCR is done. You got our samples right here, and these were the 6 samples plus the control. I have a replicate, but I'm only going to prepare these. The replicate, if you recall, wasn't necessary. Something I was doing was testing something, but I've got my PCR, and we're going to go ahead and get this ready to load on the flow cell. Right away, I am deviating from some of the things that are actually recommended, and you can make a choice as to what works best for you. So what would be the next recommended step is to quantify the PCR product using a qubit is what's recommended by Nanopore to get the concentration, because what you're going to try to do is make sure that from your PCR samples, you load the right amount. And then also it's expected that from sample to sample to sample, there may be a difference in how much product is there. I did not do the quantification. I do have a qubit, but many people may not. And so what I did do was run an electrophoresis gel to check the product size. And you can try to get something of a quantification by looking at the brightness of the bands. And then your goal really is to try to arrive at an equimolar concentration of your PCR product so that sample 1 has roughly the same amount of product as sample 2, sample 3, sample 4, etc. You have a number of options there, right? Obviously, you want things to work. So samples that do have a good amount of product are likely to work, whereas samples where you don't see any band at all, or maybe just a faint band, are unlikely to work or not work well. You have to make a decision. So I've done all sorts of different types of things. Some cases where there were some bands that weren't as bright, I reduced the amount of the concentration of what I was going to add of the samples that worked well. There have been times when I've just seen a teeny band. And because you have so much sequencing capacity, even that teeny band, there were still results for that particular sample, that particular student, but obviously they were far, far less than what was sequenced for other things. So there's a little bit of a judgment call. I guess one of the things that I would be more cautious against than not getting a particular representation of a particular sample is that we don't want to overload the flow cell. So we'll have to make some choices later. But what we're going to do is actually pool all of the samples and then clean them up using magnetic purification, and then we'll proceed with loading. So it doesn't take all that long, and I'm going to try to do all the steps right now. I've got my trusty checklist in front of me of my protocols, and one significant thing that I am going to recommend, and it's still, I guess, optional. You can really think about whether you want to use it, but I am using these special low-bind DNA tubes, and these are specifically designed to reduce the amount of DNA that actually gets stuck on the side of a tube. And an ordinary tube might not have that coating or that formulation, and so you can lose concentration or lose some samples. Now, with a PCR product, because I have a whole bunch of it, maybe you don't need to be as paranoid or concerned, but for a more precious product, you might actually really want to make sure you do this. Okay, so the very first thing that I do is I've got my products. I got everything sort of sitting here thawed. So what I'm going to do right now is go ahead and get the EDTA. So the EDTA we're going to add in order to actually make sure that we stop the reaction. You know, TAC is pretty tough, so temperature inactivation is not going to cut it. But I've got some EDTA here, and I'm going to go ahead and add 4 microliters to each of the samples. I have taken out, and when I did my electrophoresis, I ran 10 microliters of this. You, again, could make different choices as to how much you'd like to run or not, but I happen to run 10. I don't think I really have to adjust the concentration here too much because it's all going to get cleaned up. So I got a sample. You want to make sure everything's thoroughly thawed and mixed. You could spin this down. This is a really large amount here, so I'm not going to be worried too much about spinning it down in this case. The other thing that is the case at this point is all of the samples by PCR have been barcoded. So I'm going to be mixing everything anyway, so I don't necessarily need to worry about cross-contamination of the samples with each other. However, I don't want to contaminate my EDTA tube with anything that I don't want in there, so I'm going to change tips all the time, and you can make decisions again. Also, in my PCR, I happen to have done a control just to make sure that everything was clean. And there's no reason to include my control here in the actual running of the sample. So again, what I'm doing is just making sure that by adding that EDTA, that really all enzymatic activity has stopped. Just a quick little splash and mix. Gonna get rid of my control tube and spin this down. Okay, so I've added that, and the next step is going to be to actually pool these. And this time I am going to use now one of my fancy low bind tubes. And we're going to go ahead and just call this, I'm just going to call this a pool, or U pool for uncleaned. I'm not going to have all that many tubes, but I marvel at myself at how quickly I will confuse and mix things up if I don't actually have everything nicely labeled. And here I can just use one tip. Again, it's all going into the pool. Because I had looked at these earlier, they're all pretty much the same concentration. And because in my particular case, I opted to essentially, oops, touched that tip. I opted to kind of go to saturation here in terms of my PCR product, like producing the maximum. The other thing that is important here, if for some reason you had different volumes between the different PCR products, you actually need to know what the final volume of your pool is, because in a moment you are going to add magnetic beads to this, and what you're going to add is actually going to be in proportion to the amount of your total pool. In most cases, I think just, well, if you're using all of the barcodes, right, that's going to be whatever the individual sample is times 24. But make sure you know, and if you didn't know, or if you forgot, or whatever, you can measure it. I'll measure it with a pipette. I will just go ahead, I'll set it to what I think it is. And I usually set it to above what I think it is, and without getting any air, reducing any kind of air bubble. You can adjust the pipette down until you get a measurement. So I've got about 200 microliters here. So you can just measure it and make sure, because you're going to add that in proportional. And I believe, I'm not going to say it out loud, I'm just going to actually read it from the sheet. Yeah, it's 0.6 the volume that you're going to need to add. So I'm going to quickly take my calculator and take a look at that. Okay, so I've got a volume that I'm going to use. And the next thing I need are my magnetic beads. So in the tube that comes with the 16S kit are these magnetic beads. These are nice, and I mean it in the sense of, they're nice for many reasons, but I mean that in the sense of that these have mixed easily. I've noticed sometimes, depending on how long tubes have been sitting around, that it's sort of caked at the bottom. I'm not using a vortexer. This would be a good time to use a vortexer, but since these are nice and flowy, libel, whatever the appropriate adjective is, I'm going to be content with just mixing them this way. Okay, so I know what my volume is. Of course, I just forgot it. Okay. So I'm going to go ahead and add that volume of magnetic beads. So again, just before you add them, really make sure that you have mixed them well. I've set these down for a moment, so I'm going to mix it one last time. And I like to pull from the bottom. Okay. I can feel, I wasn't even looking at it, feel it, like, so there's that last drop that's on there. It's okay, I've got a little bit extra. Okay. Okay. Now, what you're instructed to do is to mix this on a hula mixer, which I do not have. I have my hands, and so I'm gonna invert it, and we're gonna do this for 5 minutes. Okay, it has been 5 minutes of giving a nice swirl in my hand. Now, the next instruction is to actually take this and spin it down. And you're not necessarily trying to spin it for a long time to get a pellet. A short spin is just fine. Just gonna open it here. Looks like I already got a balance in there, which is great. I would not recommend spinning it down for a very long time because I'm not looking to get the pellet from the action of the centrifuge, but I do want to try to get things to the side of the tube. Maybe I'm paranoid, but I think that if I were to spin it down for a very long time, I could get stuff that's kind of stuck or caked on. And that's not what I'm looking for. So got this tube. And what I'm going to do now, the tube itself, it's going to start out cloudy. I'm going to also switch to my trusty. So here's what the tube looks like after spinning it down. There is a little bit of, getting things onto the back by spinning it down. But when I put it onto the rack pretty rapidly here, everything is going to coalesce into a nice collection on the back there. And what I want to do is let that sit there for a good minute, really to collect everything. What you're looking for is for the supernatant itself to be clear. And it's really pretty clear. And everything is on the back. So I'm going to go ahead and start the wash procedure. Zoom out just a little bit. Okay, so I'm ready to go ahead and do the wash. And in order to do the wash, first thing I'm going to have to do is actually take off the supernatant. So I'm going to pipette that off. Remember, it's the original volume plus what I added of the beads. And the goal here is definitely not to touch the actual beads. So if I go in there and press down, what I'm doing is keeping the pipette tip opposite the side of magnetic beads. I put my tip in, and then I'm going to go ahead and slowly suck up the supernatant without interfering with the beads. Once I think I got it all, take it and cap it back up. you're not working with it, unless you've been told otherwise, you want to keep the cap on because the beads are subject to drying out. If for some reason you walked away, let it dry out, you would never get your DNA sample off the beads, so just be careful. So we're going to wash this twice with a ml of 80% ethanol, which I have just prepared a few minutes prior to starting this. And the wash is very simple. I've got 1 ml of ethanol right here. I know it likes to drip, so I'm trying to be careful. And I open my tube, and what I'm actually doing, I'm not trying to get the ethanol to wash down on the beads. Instead, I keep my tip opposite, and then I just let the ethanol slide in. I am not actually forcing it over that side with the beads. I'm not trying to create a current. I'm not trying to be very harsh with it, but that's it. That's a wash. And I'm gonna suck that out, keeping again my pipette tip always opposite where the beads are. Keeping it away, closing it, and doing that one more time. Okay. Okay. So now we spin it down just a moment, and the idea is to try to get every last drop of ethanol down to the bottom of the tube. Not trying to pellet it, but there is, you know, a little drop of ethanol that remains at the bottom there, just because my pipette is so big. So what I'm going to do is briefly spin it down, make sure anything that's on the side is collected to the bottom. So just a short spin for a second or two. And then I'm going to use a smaller pipette to get that last little drop out. In the meantime, not that there's a lot of meantime, so let me put that back and let the bead come back up the side of the tube. It's gonna float back up to the side. You might be able to see it there, forms a nice little bead. But in the meantime, let me go ahead and get that last little drop out. Using a smaller pipette helps. So put that in the bottom. Okay. Might there be a microscopic bit? Well, maybe not microscopic, just enough for me to see there might be. But I'm going to keep that there and I'll leave it open for 30 seconds. And that means I got to quickly get to my next thing, which is the elution buffer. It's all nice and thawed. And what I want to do is add 15 microliters of that. The point here again is not to let that dry out to cracking, but there's enough time in that 15 seconds that really vast majority of ethanol has wafted off. I've got my 15 microliters of elution buffer. And now I can go ahead and off the rack. That I can let drip onto the side here. And then close that and let my finger do the work of just resuspending that pellet. This one I find you do need to tap it a couple times and make sure that the pellet has actually resuspended. Sometimes I've seen like you get like a little chunk of unresuspended pellet. It will be like a little black dot. But this is pretty good. And we're gonna let that at room temperature, sit for 5 minutes. And then we're going to go ahead and pull that off. So I'm going to create a new tube. All right, so let's let that go for five minutes. Okay, we're ready to proceed. If you were really eagle-eyed, you would have seen I put this on ice, or I put it on my ice bucket, which I'm not supposed to do. 5 minutes at room temperature, so that's where it's been. And now what we want to do is go ahead and obtain 15 microliters of this in a clean tube. So we're going to put this onto a magnet for a minute, so you can get a 1 minute timer. And I'm going to go ahead and put that onto my magnet. The bead just slithers its way up. I'll see if I can get a nice video of that at resolution. But yeah, at this point, the bead will pull itself out of that little drop of 15 microliters, and it'll stay there on the side. But nevertheless, we want to make sure every drop is up there. So we'll give that the full minute, and then we'll go ahead to the next step. Okay, so I'm going to transfer that 15 microliters into another tube I've already labeled. It's one of the low bind tubes, and I call it my clean one, or rather the DNA loans, I call it my cleaned pool. And I don't want to remove the tube from the magnet while I'm doing this, otherwise it'll fall back in. I just get my tip all the way at the bottom. And transfer that, okay? Now the recommendation is, again, to quantify this. It's true that you do lose a little bit of DNA in the cleanup, but I'm not really concerned about this. I'm only going to take a few microliters of this. So this is actually library that's, well, it's pooled DNA that's ready for the next step, which is the rapid step. And so that could be used again and again until you, well, if you needed to do more sequencing. We can't think of any reason why you would, but you might. So we've got that cleaned PCR product that is ready to go to the next step with the rapid adapter. Okay, so I am ready to go ahead. I've got a tube that's already labeled, and it says that we want to transfer 50 femtomoles of this clean pool into a tube and get it ready for the rapid step. Kind of the issue here is that I am not quantifying it in as precise a way as is suggested by Nanopore. You can use a calculator to figure out, given the size, we know that the fragment for the 16S PCR should be, and you could use that to figure out the number of femtomoles with the cubic concentration, and we are cutting corners here. But I've seen that work just fine. So I'm actually gonna load, and this is just my number for whatever reason, 2 microliters of that into this tube and make it up to 5.5 with water. So let's get my pipettes here. And again, you can make choices based upon your experience and what you've seen work. If you are without much experience, my recommendation here oftentimes is less is more. That you're, you know, if you're confident you got PCR product, we might want to err on the side of loading a little bit too little, because we will be able to, we're sequencing, we've got plenty of sequencing capacity here. And I'd rather do that or rely on that rather than overloading the flow cell. Got my sterile water. The next thing that I need to do is I need to dilute the rapid adapter. I put that on my magnetic rack just because it's convenient. There's no beads and no reason, it's just there. And so what I'm gonna do is add 1.5 of the rapid adapter and 3.5 of the rapid adapter buffer. I'm making more than I need because I think I only use 0.5 microliter. So you're preparing here again. a little bit more than you need, and that might be something to take into account, especially if you have the opportunity to run multiple sections. Maybe in some cases, actually, you can save yourself a little bit of reagent. This is probably the most precious sample or reagent that you get. So don't drop it. We flick that gently. And we only need half a microliter of this. So make sure you verify by eye that you have the volume. It's so little. Like even overcoming surface tension is an issue there. I'll put that on ice. I'm pipetting up and down just a bit. Okay. And I can tap that, but then make sure I spin it down at such a low volume. Okay, that is going to sit for 5 minutes. And then we're ready to load the flow cell.